Welcome to Matematika. Today we're going to do trigonometry. That is, we will be solving right triangle problems. Okay, you have here a right triangle. You know, a right triangle is a triangle with a right angle. Okay, let's label this right triangle. The two sides are what we call this side right here a leg. Okay, this is also a leg, and the longest side is the hypotenuse. Okay, and I hope you remember this in your geometry, right? But this one leg here, we could say this leg is adjacent to angle A, meaning the leg that is near angle A or next to angle A. One leg is the opposite in front to angle A. So we have leg adjacent to angle A and leg opposite to angle A. If we are using angle C, the leg opposite is the side A to B, and the adjacent to angle C is the side BC. Okay. Now when we do problems, when we solve problems that is asking us to find the missing angles or angle measure in a right triangle, we usually use the relationship of, right triangle relationship. That is using trigonometry. The very famous when doing that, it's very easy for you to remember. We use the sukatua. This is sukatua. Okay? Wherein the S here stands for the sign. O stands for the opposite. And H stands for the hypotenuse. Okay, so it's easy for you when you want to find the sign, you could say opposite over hypotenuse. Where the ka in sukatua, the C stands for the cosine, A stands for the adjacent, and H stands for the hypotenuse. Okay. For tua, okay, I will move the TOA here for sokatua. So T, of course, stands for tangent, O opposite, and A for adjacent. Okay, so you got it. Always remember, when I was a student before, I just remember sukatua. Then I could plot my, solution or my relationship using sukatua. So in a case like you are asking to find an angle, let's say angle C here, we can use that as theta. So using sine theta, so that would be opposite of theta, I will move this up, over hypotenuse. Alright. Then for cosine theta, adjacent to angle C, where the theta is, over hypotenuse. So coming from Ka, C A H, C A H, so S O H. So how about the tangent theta? So tua, that means opposite over adjacent. Alright? So TOA for tua. That would not, you will not be lost. You can solve the problem. Just remember, easy to remember, the relationship using the sukatua. Alright, let's get ready. Let's have example 1 here. Alright. There is a label of this triangle. So we have opposite to the angle and adjacent to the angle and hypotenuse, the longest side. So you use this diagram. I want you to find the cosine, sine, or sine, cosine, and tangent. So I'm going to start in order to find the relationship. So using, I'll have it here. So, ka, tua. Okay. Sukatua. So if I say sine theta, O is for the opposite, H is for the hypotenuse. Alright? For sine. So, what is the opposite of theta? This one. Right? The hypotenuse is 17. That is your relationship. So, and then you can simplify that later. We're going to use that. For cosine theta, cosine is CAH. That means A for adjacent, H for the hypotenuse. So, adjacent is 15 over the hypotenuse 17. Okay? For tangent theta, TOA, tua. So O is the opposite, A is for the adjacent. So what is the opposite? 8. Adjacent is 15. So 8 over 15. There you have it. Those are the relationship. Now, using the same right triangle, find the measure of one angle A. We're going to find the measure of this angle A. And then the measure, the theta. What is angle C? Okay? So I'm going to start. I start with A, finding the angle of A, sine A degrees. A is what? Opposite over hypotenuse. So opposite of A is 15. That sine. SOH. So 15 over 17. Alright? If you want me to write it down, okay, I'm going to write it down. So sine is SU. SU is opposite over hypotenuse. So the opposite of A is 15. The hypotenuse is 17. So in finding the measure of the angle A, I hope you remember this. When you divide 15 by 17 and then get the angle, you're going to use the inverse of sine. So using the calculator, or you can get 15 over 17 and get the inverse of sine, you come up with 61.9 degrees. That is using the calculator. All right. So we have the measure of angle A, 61.9 degrees. Let's find the measure of angle C. We can still use what's the cosine of angles C, or cosine of C. C degrees. C is the opposite, right, over the cosine. What is cosine? So, ka. Okay, ka. This is SOH and this is CAH. So that means it's adjacent of C over the hypotenuse. So what is the adjacent of angle C here? It's 15, and then the hypotenuse is 17. So in other words, if you're going to find the measure of angle C, you are going to get the inverse of cosine 15 over 17. So by using the calculator, the measure of angle C is 28.1. All right, degrees. There you have it. Let's do some checking. If you want, when you have your answer like this, try to check. Me, when I was a student, I always do the checking before finalizing my answer. Take note that the measure of the angles total in a triangle, the sum is 180 degrees. Then our angle B, the measure of angle B is 90 degrees. So in other words, the measure of angle A plus the measure of angle C must be equals to 90 degrees as well. Right? So that the sum would be equals to 180 degrees. So what is our angle A? 61.9 degrees. And the angle C is 28.1 degrees. So this will come out into a 90 degrees. That means it's checked. Your measure of angle A is correct, as well as your measure of angle C. So the remaining angle in a triangle, subtracting the measure of, okay, where in angle B here is 90 degrees, so the two angle should measure up, the sum should measure up to 90 degrees. And that's how you to check if your answer is right or wrong. All right. Let's do this. Let's have solve some problems. A blimp hovers 400 feet above the stadium. A fan is standing outside the stadium. To directly view the blimp, the fan looks up at an angle of elevation. That means we have to look up. That's elevating our eyesight at 7 degrees. So approximately how far the stadium is the fan standing? Okay. Usually to understand more a problem, it's better to make a sketch, draw a diagram. I could make this as step 1. When you do problem solving like this in a situation, it is much easier for you to draw. All right. Let's say there is a stadium right here. It's not good. Say this is a stadium. Now, there is a blimp. I would try to use this. A blimp that is hovering. That means hovering at the somewhat like more or less as at the top of the stadium. All right. Let's say this is the blimp. You're asking, what is a blimp? All right. It's somewhat like an airship that is used for TV coverage. It looks like an airship. Okay, anything that is being placed at the top, and somewhat like a little bit like a satellite, but it's not that thing, because a satellite is far from from our space. But a blimp is somewhat like a small airship that is used for TV coverage, used for tourism, used for advertising. Okay. So in this situation, there is a blimp that hovers 400 feet above the stadium. So this is the stadium. There is a fan, a fan that is standing. Okay. Say this is the location of the person that is standing right there. And then he was looking at, let's say, okay, this is Okay, I'm gonna do that. And he's looking at the, the blimp. Right there. Okay? More or less. I have that. And what else is given? 7 degrees. All right? What else do we need? That is the angle of elevation. All right. Let's do step 2. So we have an idea how it looks like. For step 2, let's get the triangle from here. Okay, make a sketch of the triangle. We have a little bit how it looks like. And somewhere here, it's 90 degrees. Right there. Right? This is 7 degrees. And then this is 400. And from the stadium up to the blimp prayer, that is 400 feet. The question is how far the fan is from the stadium. So we're asking with the distance, d. All right, so we have an idea now. Okay, let's solve. Step 3, solve. What relationship we could get if we have an angle right here? That is, we could have opposite over adjacent. This is the opposite of angle, and this is the adjacent of the angle. Okay? So I could have, what is opposite adjacent? Tangent of 7 degrees. That's opposite over adjacent. 2. Okay? Opposite over adjacent. So what do we have here? 400 is the opposite side of 7 degrees, and the adjacent side of 7 degrees is d, which stands for the distance. All right? So the equation would look like this. Tangent of 7 degrees equals 400 over d. So we transpose. That would be d would be 400 over tangent 7 degrees. Okay. Might as well, we need a calculator here. So we have, 400. What is tangent of 7 degrees? I want you to check. Get a calculator and check. And tangent of 7 degrees is 1228. So that means you have, or d is equals to 3,258 feet. The fan or the person is 3,258 feet away from the stadium. Now let's check to see if that is reasonable, If this is, okay, we're gonna check. If this is 7 degrees, that means this is 83 degrees. 90 minus 7, that's 83. Remember, the sum of the angles in this triangle is 180 degrees. Okay. So the side opposite 80 degrees, 83 degrees. The side opposite 83 degrees angle, which is 3,258 feet. Isn't it? It's larger than, what is the side opposite the 7 degrees? Larger than the side opposite the 7 degrees, which is 400 feet. That means this side, if your angle is bigger than the smaller one, so the side opposite should be bigger also compared to the opposite of the smaller angle. So that means your answer T equals 3,258 feet is correct. Because if the case happen that your angle is big and then the side is smaller than the other side opposite the smaller angle, then there is something wrong with your solution. All right? I hope you remember to stop doing this thing. This is, using trigonometry. Okay, let's have one more problem. Okay, this is a very famous problem actually, a kite problem in trigonometry. Okay? You fly a kite 4 feet off the ground with 300 feet of string. There is a 40 mile per hour wind, and the kite forms a 29-degree angle from the ground. How high is the kite from the ground? Okay. What we're gonna do first, we'll make a sketch to understand. So this will be step 1. I'm doing the step by step here. Okay, I need my roller. You. Okay. So a person, you, are flying a kite. Say the kite is somewhere here. All right. Okay, I'll draw a kite. My drawing is not that good. Okay. So a kite is there. This is the ground where you are standing. All right. Now it says the kite is 4 feet off the ground. That means above the ground is 4 feet. So I will make somewhere where the kite started to fly, where you started to fly the kite. I could draw it here. Give me a second. Right there. So this is 4 feet. All right. And this is also 4 feet from here. So what is the question? The question is, how high is the kite from the ground? So from here to the kite, so I'll just make something like this. H. How high? So we know already that it is 4 feet off the ground. So might as well we're gonna find this height to get the total height, right? So we have to find from here to the kite. I could call that as y plus 4. And that's the idea of how you're going to, solve the problem. The string here is 300 feet. What else do we not need? A 29-degree angle that is made by the 40 per hour wind. All right. Now, let's take the triangle. Let's isolate the triangle. This is step 2. Step 2, isolate the triangle. In order for us to get the relationship, okay? The triangle is right here. I could make a small triangle. It stands for the y side. All right. There you go. So we have 29 degrees here. This is 300 feet. And this is y, the one we are looking for. This is a right triangle. Okay. Since we have a right triangle with, an angle of 29 degrees and a hypotenuse, we can use the function, sine function, opposite over hypotenuse. Okay? Sine, that is so, in sukatua. So sine, what's the angle? 29 degrees is y over, opposite. This is the opposite. This is the hypotenuse. So hypotenuse is 300. So cross multiply, y becomes 300 times sine 29 degrees. Using your calculator, get the sine of 29 degrees. which is 0.485. So y is 145.4 feet. Is y the answer? No, it's not. It doesn't answer the question. The question is how high is the kite. So this is the height of the kite. Okay? So we just get this value of y, which is 145.4. So to answer the question, you add the y value, 145.4 plus 4. So the height of the kite is 149.4 feet. This is the answer. Since the kite is 4 feet above the ground, so we need to add. That's it. All right. I hope you, this is step 3, by the way. Step 3 is we are solving. Okay? So, you got it. Today we reviewed trigonometry and then using the right triangle, solving the problems. Okay. I hope you hit the like button and please subscribe my video, my channel. See you on my next video, everyone.